Rewrite the question so that it is a statistical question. The first question says, how long is my pet goldfish? We could rewrite this to talk about more than one goldfish to make it a statistical question. It might sound something like this. How long is the typical fish at my town's pet store? Then you're testing multiple fish from the same store. There will be some variability in how long the goldfish are. Finish rewriting the remaining questions for your warm-up. Number 1. Each student in Tara's 6th grade class measured their heart rate in beats per minute, also known as BPM. The class then created the following dot plot. Use the dot plot for parts A through J. How many students are in Tara's class? Each one of these dots represents one 6th grade student. So if we count up all the dots, that will tell us how many students are in her class. There are 25 dots, so that means there are 25 students in her class. B says what is the lowest heart rate? So we're looking for the dot that is at the lowest number on our number line. And the dot that is the lowest on our number line is at 55. So the lowest heart rate is 55 beats per minute. Part C asks for the highest heart rate. So we're going to look at the one that falls the highest on our number line. The dot that is the highest on the number line is at 85. So the highest heart rate is 85 beats per minute. How many students have a heart rate greater than 77 beats per minute? So we're going to count the dots that are over 77 on the number line. So here's 75, 76, 77. So we don't want to count the dots above that. There's 1, 2, 3, 4, 5 students above 77. We have additional questions on the next slide. E, what fractions of students have a heart rate less than 72? So we're going to count all the ones that are less than 72, and that is out of 25 students total. Here is 70, 71, 72. So we're going to count all the ones less than 72. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 are less than 72 beats per minute. What heart rate occurs most often? To find the heart rate that occurs most often, we're looking for the tallest stack, because that means that multiple students had that heart rate. You can see that the tallest stack is at 71, and there were 4 students with a heart rate of 71 beats per minute. G asks, what heart rate do you think describes the center of the data distribution and why? If we look at the data here, ignoring the rest of the number line, and we looked at the center appears to be somewhere around 70 or 71. 71 has the most often, and it's also pretty close to the middle of this data set. Do any of the heart rates seem much higher or much lower than the other heart rates? If so, which ones? Well, 55 does seem quite a bit lower than the rest of them, and it's kind of far off to the left side. A new student joins Tara's class. This student's heart rate is 80 beats per minute. Add the dot to the dot plot for the new student's heart rate. So we need a dot at 80. There's already a dot at 80, so we're going to include one above that dot to show that it is two students with a heart rate of 80 beats per minute. Then Jay asks, how does the new student's heart rate compare with the heart rates of the other students in the class? This new student's heart rate is greater than the majority of the students in the class. So we'll say the new student heart rate is higher than most of their classmates. Here is another data distribution. This is based on the number of textbooks that each student has. How much do you think the values in this data distribution will vary? Since it's not as spread out, we would say it doesn't have as much variability. There is some variability because they're not all on the same number, meaning not everybody in her class has the same amount of textbooks, but it's less spread out than the previous distribution. The heart rates was from 55 up to 85, whereas the textbooks only go from 5 to 8. So there is less of a spread in this distribution than in the heart rate distribution. Tara's class is interested in the typical height of students in their class. How much do you think those values will vary? What are some data values you would expect? Well, if we're looking at inches, you might expect somewhere around 60 inches. That would be somebody who is 5 feet tall. There should be some variability because we'll have some people who are shorter and some people who are taller. So here's that distribution. Which of these is more spread out? Well, the data values vary more in the height than in the textbooks. There were only 4 different values for textbooks, but there's several different values for their heights. One way that we use to describe the spread of a distribution is to talk about what's called the range. The range is a measure of spread based on the difference between the maximum value and the minimum or the least value in the data set. So this one goes from 66 and 49. And this one went from 8 to 5. This one has a larger range because there are more values in between 66 and 49 than there are between 8 and 5. For problems 2 through 4, list possible data values that could be collected to answer the question. How many siblings do students in your class have? Well, we could have values from 0 if you're an only child. Maybe some people have one sibling or two siblings or three siblings. We may even have people who have 4 siblings. What is the typical arm span of a student in your class? Well, your arm span is usually similar to your height. So I would expect maybe 60 inches or 55 inches or perhaps 62 inches, 57 inches. In what year were students in your class born? Well, depending on how old you are, it might be something like 2012 or 2013. You may have 2014 or 2015, depending on what year you're watching this video. Which of the data distributions in problem 2 through 4 will vary the most and why? I think the arm span will vary the most because there are many different measurements. Which of the data distributions in 2 through 4 will have the least variability and why? My prediction is that the year they were born will have the least variability because you should all be about the same age in 6th grade. The 4 dot plots show data sets collected to answer statistical questions. For problems 7 through 10, match the statistical question with the appropriate dot plot and explain your reasoning. What are the ages and years of 4th graders in a school? So we have several dot plots to choose from. D is probably not the ages of 4th graders because they wouldn't be 58 years old or 1-year-old. And they probably don't range from 0 to 8 years old if they're in the same grade. So my prediction is that dot plot A matches the ages of the 4th graders. You see 9-year-olds and 10-year-olds. And the reason is because most 4th graders are between 9 and 10 years old. Eight, what are the heights in inches of the players on the boys basketball team? Well, we wouldn't expect the height to be 0 inches or 1 inch. So dot plot D is likely the best for this one. They should be between 58 to 66 inches tall. 9, how many hours of TV do students in our class watch on a school day? We still have dot plot B and C to choose from. In a school day, you're at school for quite a while, and then you sleep part of your day. So I don't predict that they would be watching 8 hours of TV on a school night. but perhaps a few students watch a lot of TV. So our choices are between B and C. Let's read the last one to make sure we've selected the correct one. How many different languages do students in our class speak? Well, I would think the majority of people speak one language, and then there's a couple of people who can speak multiple. I doubt we have anyone who speaks 0 languages in our class, but we might have some people who speak or watch 0 hours of TV. So dot plot C makes more sense for the languages, and B would make more sense for the TV. That is the end of lesson 2 for data distributions. We will continue working with dot plots and statistics in the upcoming lessons.